Okay, some other features that you would expect to find, other lines of evidence to support the idea that organisms change throughout time, is the presence of atrophied structures or vestigial structures. Generally, these atrophied structures are non-functional, but they indicate that in the ancestors, there was a purpose for them. And an example of this in humans are wisdom teeth. So you can see here in this x-ray taken of me 20 some odd years ago that there are 4 wisdom teeth present and all of them are impacted. So probably 80, maybe even a greater percentage of the population has impacted wisdom teeth. And what this means is when that third set of molars begins to grow in, there's no room in the jaw for them, and they grow at an angle into the second molars. This can result in pain and at times abscesses, infections, and prior to modern antibiotics and surgery, this would often result in death. So if these are bad things that can result in death, why is it that humans still have them? It would seem that bad traits should be removed. And yet, despite evolution, they have not. So this seems to be a little bit of a disparity. But if we think about it, it actually makes a lot of sense. If you think about when it is that most people begin to have trouble with their wisdom teeth, it's in their generally late 20s or early 30s. And by this time, many adults, especially if they're not in a first world country, have already reproduced. People will begin to have children in their late teens, early 20s, and so by their late 20s or early to mid 30s, when wisdom teeth are a problem, they've already passed the genes that code for grow wisdom teeth onto their children. And so it can't be removed from the genome of humans. So why do we have this at all? Well, any trait that we possess, we must have because our ancestors had them. So if we look at organisms that are ancestral or are derived from a common ancestor, we can look at other primates, so things like apes. And if we think about what a mature adult ape looks like, think about if you're going to play zoo with your nieces or children or cousins or whatever, right? You're going to maybe thump your chest and maybe knuckle walk. And another thing that you're going to do is you're going to kind of jut your lower jaw out because non-human primates have a much longer jaw than humans do. We retain the more baby characteristic of a short jaw. So all the other primates have a third growth spurt in which their lower jaw and their actually both jaws are expanded and their snout lengthens. But we don't get that. So we still have the genes that code for build a third set of molars, but we don't have the gene that codes for give us a third growth spurt. And so for many humans, we just don't have room in our jaw for these wisdom teeth. But we can't remove them from the human genome because it happens that the problems associated with wisdom teeth occur after reproduction. And so this trait cannot be removed. And of course, it's not just humans that have these vestigial structures or atrophied structures. We mentioned how horses are derived from ancestors that had 4 toes, and occasionally extra toes will be found in horses. Generally, again, it's a little remnant that is not functional, but there you have it. Okay, marine mammals such as whales, and as is the case with the dolphin here, are evolved from ancestors that were terrestrial and had hind legs, and they will often, especially as a fetus, begin to grow legs and pelvic bones. Oftentimes it'll get to a stage of being cartilage and then it'll be reabsorbed by the body, but occasionally they are actually born with a little bitty nub of a back leg. And the same thing with flightless birds. Ostriches and emu and the fossil Gastornis, which was called the terror bird, right, had these kind of ridiculous little T-Rex-like wings. Definitely, these wings cannot be used for flight, but why do they have them? Well, of course they have them because their ancestors have them. They don't use them currently, but they still have the genetic coding that develops wings. Okay, and another line of evidence, if natural selection and the resulting evolution that will occur from that are true, then you would think that organisms, even if they're unrelated, that live in the same environment or have a similar lifestyle, will evolve similar external features. So it happens that whenever it's cold, predators will tend to get these expanded canines, these saber teeth. And this is the Smilodon, the North American saber-toothed cat, and this is a South American saber-toothed marsupial. So an animal like a koala or a possum that has a pouch, but was a carnivore. And you can see, even without a tremendous amount of knowledge of bone structure, that the shape of the back of the skull is very different. The shape of the jaw is certainly very different. The shape of the teeth and the position in the jaw of the teeth, how far back relative to where the eye is, the back teeth are. These are not very closely related organisms, but they converged through this, the presence of these analogous traits. Because they were in a cold environment and because the prey animals were large, these saber-toothed teeth are an advantage. And so regardless of the organism, whether it's a placental mammal or a marsupial, whether it's in North America, South America, or Australia, they all converge on the same body plan of having long teeth. And of course, it's not just with terrestrial animals, but marine animals all have the same body shape, sort of this streamlined torpedo body shape. And this is true of cartilaginous fish, like sharks, and bony fish, like the garfish here. Both fishes, but not very closely related, but they have a similar body plan. And the ichthyosaurs, which were marine reptiles, so it started out with something sort of crocodile-looking, and it merged onto the same body plan, because when an organism is living in a marine environment, any mutation that helps it swim more efficiently will be taken advantage of. And the same thing with mammals. We saw that dolphins and other whales are derived from terrestrial animals, sort of like a hippopotamus, and yet they too have this streamlined torpedo-shaped body. This is a perfect example of analogous structures or convergent evolution. So think about these, and afterwards there'll be one more very short video for this first part of evolution.